Welcome to lecture series on data structures. In today's lecture series, let us discuss about the algorithm used for constructing minimum spanning tree. So before we go to discuss about the algorithms, let us have a quick recap on the problem statement. We have already discussed this problem statement when we are discussing about Dijkstra's algorithm, which is copy self-to story. So hope I need not repeat it again. So the main aim of Kapi is to visit all the planets in the shortest span of time. So this is what the problem statement is all about. So these are the topics we have discussed earlier. We have seen what is connected graph, undirected graph, what is spanning tree. We have seen what is the edge weight mean, what is the weight associated with each edge mean. And we have seen the need for Dijkstra's algorithm. Now let us discuss about the two algorithms used for constructing minimum spanning trees. So as I have discussed in the earlier lecture video, the two main algorithms used for constructing minimum spanning tree are Prim's algorithm and Kruskal algorithm. First, let us see the working of Prim's algorithm. So Prim's algorithms works as like this. It initializes all the variables or the vertices and it processes the input data and the core logic is executed and it generates the output. So this is the working behind Prim's algorithm. Now let us see how it works. So here the connected graph is given. So you should remember you can construct a spanning tree or a minimum spanning tree only for a connected graph. For the other graph, and it has to be connected undirected graph. So for other kind of graph, spanning tree cannot be constructed. So now look at this graph. So we will start from the vertex B. Now here B is chosen as a source vertex. So you will identify the adjacent vertices of B, which is C and D, and update the distance. And next of these two, vertex D has a minimum cost, which is 4. Now visit vertex D. Adjacent vertices of D is C and E, and its minimum cost is 2 and 1. So here you need not calculate the distance from single source. You need to update the distance from the vertex that you are visiting at that time. So distance to reach C from D is 2 and to reach E from D is 1. So now the vertex E has the minimum cost and so adjacent vertices of E are D and C. D is already visited. The only vertex which is left unvisited is C. So distance to reach C is 6 from E, but already it has a minimum distance 2. So do not replace. So now the next vertex to be visited is C. Adjacent vertices of C are B and A. B is already visited. Only vertex left is A. So distance to reach A from C is 3, which is a minimum distance. So you can replace. So this is a minimum spanning tree for this particular graph. For this graph, you will have only one minimum spanning tree since all the edge weights are distinct. So this is the logic behind the working of Prim's algorithm. So here is an assessment. So for this particular graph, what will be the minimum cost of the spanning tree that will be constructed? So answer would be if we start from vertex A. So from A to B, the distance is minimum 10, and from B to D, it is again minimum 6. From D to E, it is 11. So the total minimum cost would be 27. So the answer is option C. Now let us discuss about the working behind Kruskal algorithm in constructing a minimum spanning tree. So it sorts, the first step in Kruskal algorithm is it sort all the edge weights in ascending order of cost. So all the edges are sorted in ascending order of cost. So iteratively you will add the edge that do not form a cycle. If an edge is found to form a cycle, that edge is discarded. So for this graph, so let us start. First edge that has to be added is A to B because it has a minimum cost. Next one that has to be added is E to D, and next add it does not form a cycle, it is added. Next is B to C, again that will be added. Then C to D does not form a cycle, it is added. All the other three remaining edges, when added, it forms a cycle. So all the remaining three edges, A to C, A to D, and A to E, are discarded. So that is the minimum spanning tree for that particular graph. So what will be the edge cost or what will be the weight of the minimum spanning tree for this particular graph using Kruskal algorithm? Now C, A to C can be added. So cost is 2, B to F can be added 2. C to F can be added, D to F can be added. So the total cost is 12. Any of the remaining edges, yes, it can be added. D to A, E can be added. 7. So 12 plus 7 it is 19. Any of the remaining edges when added, it forms a cycle. So the weight of of the minimum spanning tree that can be constructed for this particular connected graph using Kruskal algorithm is at 19. So option D is the answer. So now let us summarize what we have seen so far. In We have seen what the in this lecture video about graph data structure, we have seen the definition for graph, types of graph, and terminologies associated with graph data structure. We have seen what is the algorithm used for constructing a shortest path. We have also seen what is minimum spanning tree, what is a minimum spanning tree, and algorithms used for constructing minimum spanning tree. Hope you understood this topic. Let us discuss some other topic in the next lecture video. Thanks for watching.